Welcome to GrayYeon Math. We are asked to solve this problem. We have three circles, and these three circles are actually congruent and all have a radius of 10 units. And they are uh, put side by side, in that their centers are actually collinear. And from the center of the first circle on the left is drawn a line such that the endpoint is actually the point of tangency to the third circle. Okay, and because of that, it passes through, this line passes through the second circle via 2 points A and B, and we are required to find the length of AB. Okay, so a hint on the first thing we have to do is, since we are given a point of tangency, we can actually draw a line from this point of tangency to the center of the third circle. And therefore, since this is a point of tangency, then this should be 90 degrees. And it is also given that these centers of the three circles are actually collinear, so we can draw a straight line, okay, from circle 1 to 3 and passing through the center of the second circle because they are collinear. Okay, so next is we take note of the given, which for the radius, which is 10 units. So this is 10 units. And again, the radius is 10. So this gives us, since this is 10, this will be 10, and this will be 10, and this will be 10. So this gives us actually 20 units for this length. So 20, and this is 20. Okay. Okay, so next is we draw a line from the center of the second circle that will be perpendicular to the segment AB. So if this is perpendicular to AB, then this, of course, will have the same slope, or it will be parallel to this, the radius of this third circle, the one we labeled 10. So we can actually call this an unknown distance. So this is, let's call this as y. Okay, so next is we need to get the value of y. So to get the value of y, we need to compare this smaller right triangle with this larger right triangle. Uh, the larger right triangle, I mean, is the one with the shorter leg of 10 units, this one, and the hypotenuse as 20. Oh, the hypotenuse as 40 units. So that is the largest. So we compare the smaller triangle. Okay, so for the smaller triangle, we can actually uh, this y, since they are actually similar. So y over this hypotenuse, y is actually the opposite side with respect to this angle. So let's call this as theta. So the opposite is y over 20 is equal to 10 over, it is the opposite side, the 10 for the larger right triangle. So 10 over 40. So we just need to cancel this first. So this becomes 1/4. So cross multiplying, we have y is equal to 20 over 4. So y is equal to 5 units. Okay, so you may have noticed as to why we need to get this length because actually it is, as you can see, closely related to the length AB being perpendicular, and also this segment, the 5-unit segment, actually is a perpendicular bisector because it can be a perpendicular bisector of this line AB because it is a radius uh, perpendicular to this line AB. I mean the radius, if you continue this, since it is from the center, this could be radius. Okay, so from this point onwards, we can actually have two options on how to get this length AB. So one is if we draw this radius again from the center of this circle, okay, to any of points A or B. So if we choose A, it will become a right triangle, and this hypotenuse is simply 10, and this is half of AB. So let's call this as X. So we simply get X by one leg of this right triangle. So uh, the hypotenuse is 10. So 10 square is equal to X square plus 5 square. So X square is equal to 10 square, which is 100 minus 25. So this becomes 25, and this is 100. So 100 minus 25 is equal to x squared. And x squared is equal to 75. So if we take the square root of both sides, so 75 can be written as 25 times 3. So 25 times 3 is equal to square root of x squared is x. So x is equal to 5 square root of 3. Okay. 5 square root of 3 units. And for the length of AB is simply equal to 2x. So AB is equal to 2 times 5 square root of 3. So AB is equal to 10 square root of 3 units. And that is our answer if we use Pythagorean theorem. Okay, so another way is we can actually use the intersecting chords theorem. So we just need to continue this 5-unit segment to the other point of this uh, circle, and this is actually 10. Okay, so and for the next chord, this is actually x also. So since they are divided into two, we can make the length of each segment to be x and x. And since this is 5 from the center of the circle, then this should be also 5. Okay, so for intersecting chords theorem, so we take note of where they intersect this point. So this is the divisions as to which the segments the segments that we need to multiply to each other. So for this segment, this will be, for this part, it will be 5 plus 10. So that will be 5 plus 10. So 15. So multiplied by 5. That is for the first segment. I mean, first pair of segment. And the next pair of segment is the two equal segments, x and x. So it is equal to x times x. Okay. So x squared, since this will become uh, 5 plus 10 is 15. So x squared is equal to 15 times 5, or x squared is equal to 75. And 75 can be written again to as uh, 25 times 3. 25 times 3. And if we take the square root of both sides, it will give us x is equal to 5 square root of 3. And again, AB is equal to 2x. So AB is equal to 2 times 5 square root of 3. So same answer. AB is equal to 10 square root of 3 units. Same answer as we got earlier for the Pythagorean theorem. So thank you for watching until the end of the video. Please like the video if you liked our solution, and don't forget to subscribe to the channel and hit the bell icon so you will be updated for more math videos like this. Thank you. Bye.